Okay, guys, we're going to look at 6C, which again is using augmented matrices to solve systems of equations. We've already done a little bit of this in the intro to Gaussian elimination video. So now we're going to do another example. And I want to try to do an example where I had all three unknowns in my matrix, which actually isn't true for example 7. So instead, we're actually going to do question 1, because you can see here I've got x, y, and z in all three equations. So I want to try to formalize this process and kind of have a few steps that logically we can think through to help us solve our matrix. So you can see in the textbook, they've got a series of like step 1, step 2, step 3. I'm kind of do a similar idea here, except I'm going to kind of make it more clear what each step is trying to achieve. Here with step 1, we are trying to form an augmented matrix. So let's make our augmented matrix. That's going to look like our coefficients. 2, minus 1, 1, 1, 2, minus 2, minus 2, 1, 3. I draw my line, and now I do my solutions, minus 7, 7, and minus 1. So there's my augmented matrix for question 1, part A. Once I have my augmented matrix, my coefficients on the left-hand side of that line, my solutions on the right-hand side of this line, the second step that I want to do, and this is really important because we didn't talk about the order in which we wanted to eliminate our variables in the first video. We actually do have an order or a process that is going to help us to eliminate some of our terms. So step 2 is going to be to eliminate A21. And what I mean by A21, sometimes this is different names, but this is kind of what we looked at when we first were labeling our matrix. A21 refers to this element here. So second row, first column. I want to turn this number 1 here into a 0. If I turn that into a 0, that's sort of the first part. Then the next step is going to be to turn this number here into a 0. And the final step is going to be to turn this number here into a 0, creating my triangle. And we'll talk about the operations we can do to do that. There's a good reason why I want to eliminate the top one into a 0 first, then the bottom one, and then do that third one. So step 1, form the augmented matrix. Step 2 is start making the zeros to create my triangle. Now, there's a few different methods I can use to get a 0 entry. So let's make a little separate box over here. Just call this methods to eliminate, and this can apply to eliminating any of those three. So the first thing we can do is we can actually swap the order of my rows around. So I could take, as an example, I could take this whole row here, and I could take this whole row here, and I could move that row. I could move this row up to 2, and I can make this my third row as an example. I can swap the order of my rows around. I'm more than happy to do that. I'm just going to put it back to how it originally looked, and then we'll decide if we think that is or isn't a good idea. But I can swap my rows. If I already have a 0, like let's say I have a 0 here to start off, maybe I want to swap that row. Maybe I'd want to swap these 2 rows to get my 0 at that element straight away. So we can swap rows. That is a very useful method. So first step is to swap rows. Step 2 is to multiply rows by, I'm going to write fractions or integers. So what I mean by fractions or integers, I could halve a row, I could quarter a row, I could double a row, I could triple a row. So I could times by 1, 2, 3, a half, a third, etc., to kind of adjust my numbers that way. And the third step is to add a multiple of one row to another. So they're my methods to eliminate my rows. You can see they're here in the textbook as well. So we can exchange 2 rows, multiply row by non-zero, add a multiple of one row to another row. I've kind of slightly changed up the language, but it's the same idea. So they're the kind of the 3 things we can do to help eliminate my rows. So I can add / subtract my rows, I can multiply, or I can swap my rows around. So with my first step being to eliminate this number here, if I look at row 3, well, if I halve row 3, you can see half of 2 is going to be -1. I could add these 2 rows together to eliminate variable 1. There's actually a lot of different ways to eliminate variable 1. So any process that gets rid of it is fine. A question that I thought some of you might have is, well, why can't I just subtract 1 from here, from here, from here, and from here? Just subtract 1s all the way along to make this element here 0. I'm being consistent. Everything's being minus by 1. Is that not balancing my equation? Just bear in mind that this is x, y, z. So that means I have to subtract 1 lot of x, 1 lot of y, and 1 lot of z. which would also mean I have to subtract one lot of X, one lot of Y, one lot of Z off this side here, which has created a whole other problem. So that's why I can't do that. I need to actually use my rows because my rows already have my numbers in terms of X, Y, and Z. So I'm not just eliminating the coefficients. I also do need to consider they are technically algebraic terms here. I'm just looking at the coefficients of my algebraic terms. Row 1 is going to stay exactly the same. And for row 2, I'm going to do... I actually have two options here for how I want to proceed. One of my options is I double row 2 and subtract that from row 1, or I double row 2 and add that to row 3. Or I can halve row 3 and add that to row 2, or halve row 1, add that to row 2. So like there's a lot of different ways I can approach this question. As long as I get a 0 here, as long as this gives me a 0, it doesn't actually matter how we get there. I think the easiest way in terms of getting whole numbers would be to double row 2 and then add that to row 3. So this is going to become my new row 2 is going to be equal to 2 lots of row 2 plus row 3. So if we go ahead and do that, that's going to give 0 because that was the whole purpose of what I was trying to achieve. Then I have 2 times row 2, which is going to be 4. 4 plus 1 is going to give 5. 2 times minus 2 is minus 4. Minus 4 plus 3 is going to give minus 1. And then 14 minus 1 is going to give 13. And my row 3 is going to stay exactly the same. So I've got my 0 there. That's a big tick. Now step 3 is going to be to eliminate A31, which is row 3, column 1 being this term here. To do that, actually, if we have a look, well, I've got minus 2, positive 1, minus 1, positive 2. So I'm actually going to wind up eliminating both those variables if I just simply add those two equations together, which is nice and convenient. So I'm not going to need to do a step 4 for this particular solution. However, just note that it's not always going to turn out that way. Sometimes you might require a 4th step. So if I go ahead and I add those two equations together, so again, my first row is going to stay exactly the same. My second row now is going to stay exactly the same. And row 3, my new row 3, is going to be equal to just row 3 plus row 1. That's going to give 0. 1 minus 1 is going to give 0, and then 3 plus 1 is going to give 4 is equal to minus 8. So I've got my triangle. This is the whole point of what I'm trying to do. I'm trying to eliminate to get my little lower triangle of zeros on the bottom side here. This question did turn out quite nice because I could easily eliminate my A32 term. I could easily eliminate that at the same time as eliminating this term here. Otherwise, I'd require a 4th step, which would be to eliminate A32 or to eliminate, make this term into a 0, assuming I didn't get a 0 just then. So that's quite nice. I'm going to write step 4 down anyway, because I'm sure you guys will have a question where you would need to do 4 steps. So step 4 would normally be to eliminate A32, which would be to make this term 0. Like I said, in this question, it just happens to turn out to be 0, which is nice. So assuming I didn't do that, I would eliminate that, get my triangle. Because I already have my triangle, I'm going to move on to step 5, which is going to be to sub Z into X, or into row 1 and row 2 to find X and Y. So let's solve for Z first. Z, or for Z, I should say, is equal to -8. So Z is equal to -2. If I sub Z equals -2 into R2, that's going to give 5Y minus -2 is equal to 13. So that means Y is going to equal 11 divided by 5. If I sub Z equals -2, Y equals 11 over 5 into row 1, then that is going to give 2X minus 11 over 5 minus 2 equals -7. So if I add 11 over 5 and I add 2, that means that 2X is going to be equal to -7 plus 11 fifths plus 2, which is going to give -14 fifths. So therefore, X is going to equal -7 over 5. Therefore, X equals -7 fifths, Y equals 11 fifths, and Z is equal to -2. There are my 3 solutions. Now, we did talk a little bit about how these can be represented as a geometric solution. What this essentially means Now, if I was to interpret this as a geometric solution, we have a unique solution because I just get one number for each of my terms. So it's unique, and therefore those three equations I had, which would be 2x minus y plus z equals -7, x plus 2y minus 2z equals 7, and minus 2x plus y plus 3z equals -1, all intersect at coordinate points -7/5, 11/5, -2. So the same way we normally do coordinate points is x and y. Now it's just x, y, z. Okay, so that's it for our Gaussian elimination. Step 1, form our augmented matrix. Step 2, eliminate A21, eliminate A31, eliminate A32. The ways I can eliminate is swap rows, multiply rows by fractions or integers, add a multiple of one row to another. And you can see I have a few examples of doing that down here. I actually find Gaussian elimination is kind of a fun-ish process as far as math goes. So hopefully it's starting to click a little bit in our minds. We can have a go at 2B, have a go at 2C, and then we'll talk about some geometric interpretations in the next example. And that will then allow us to do a few more of these questions.